Hello everyone, my name is Master Jamal and I have co-authored this with Dr. Charit Pereira. We both from Cardiff University. The topic of the poster is Explainable Sensor Data-Driven Anomaly Detection in Internet of Things Systems. Deep learning models have been in use for anomaly detection in IoT systems, and it is a highly researched area. However, the key hurdle and that we have tried to address in this work in the wider adaptation of deep learning models for anomaly detection has been its lack of transparency, or its inherent nature as a black box models, because there's a very low visibility on the inner workings of the deep learning models. We have proposed a method which aims to provide explanations for not only the deep learning models in a low time latent and computationally efficient way, but we've also generated an explanation dashboard which covers different aspects, or tries to present a complete picture of the detected anomaly with different perspectives, so that personas who are interested in different aspects of the detected anomaly can use the dashboard to understand the detected anomaly. For the detection of the anomaly, the methodology that we have picked is the LSTM autoencoder, which is a pretty common deep learning model which tries to replicate and is an unsupervised deep learning model which uses prediction-based techniques to detect the anomalies in data streams. For the generation of the explanation, the root method that we've used is the game theory based Shapley additive explanations, or SHAP explanations. We've used a derivative of it to generate quick explanations called the tree SHAP. The proposed method is a dual surrogate model which uses a post hoc model agnostic which generates post hoc model agnostic local explanations. I'll shed some more light on this particular method later on in the presentation. We've used the data set called the SWAT, or the Secure Water Treatment data set, which mimics an industrial process of a 6-stage water treatment process. It has around 15,000 observations with almost 78 IoT devices with various data types, including continuous, discrete, and categorical data types. So moving on, I'll now talk you through the process flow of detecting the anomalies, and then subsequently generating the explanations for the deep learning model. The first half, till the diamond of the process flow in front of you, is pretty self-explanatory. It's how the anomalies are detected with the comparison of the output of the LSTM autoencoder, which is trained to accurately reproduce the input data sequence with very low errors. If the error is above the threshold value, then that is the detected anomaly. And the LSTM autoencoder is used so that it is capable of not only collecting the point and collective anomalies, but also the contextual anomalies. Now I'll explain in more detail the dual surrogate model, or the main method that we have proposed in this work. It is the dual surrogate model. So we train two surrogate models based on a random forest to replicate the output of the LSTM autoencoder, or our deep learning model. One is trained on the all the feature. One is trained on all the other features apart from the feature in question, and the other surrogate model is trained on the past values of the feature in question and the temporal dependencies that the deep learning model uses to output or uses to generate the output. For that, and so the first model is both the surrogate models, after being trained on the respective features that I just explained, are then explained using a tree SHAP, which is a derivative of the SHAP explanation model. The tree SHAP is used because it is less complex as compared to the deep learning model, and it is then trained to mimic or trained to output the same output as the deep learning model for that brief context, that brief data stream that is in question. So that way it uses less computational or resources and produces a quick explanation. Apart from the explanation of the deep learning model, we also create the explanation dashboard, which is an interactive dashboard that the user can interact with, and user can then select whichever aspect of the detected anomaly feature and the time window that they want to probe. The explanation dashboard presents the explanations in a layered manner using the provenance or the historical logs. We have 6 layers in our explanation dashboard, and number 1 being 1A tells the user when did the anomaly occur and how much anomalous it was. 1B then tells the user about the potential implications that that particular anomaly could have. 2A is then sheds some light on how is our model detecting the anomalies, and 2B tells the user to gain the user's trust with respect to how well the model learn from the input data sequence. 3A and 3B are merely the output plots, force plot and dependency plots for the 2 surrogate model that I just explained in the previous step. Thanks a lot for your time.